Hey everybody, and welcome to Chapter 4. We are talking about psychological measurement in this chapter. In the previous chapters, in the previous videos, at the very end, I showed you a dog. I can't do that this time because I only have 3 dogs, and so can't do it at the. I can't go out and steal somebody's dog and show it to you. But if you hang out till the end of this video, I don't know, I'll figure out something, some surprise to show you for those of you that make it to the end. Alright, so getting right into it, this chapter I think this chapter benefits a lot from examples. If you are following along the textbook, I like our textbook. I especially like that it's free, but it doesn't always give a ton of great examples. So a lot of what this video is going to be is kind of reiterating a lot of the themes and ideas from Chapter 4 in your textbook. I'm going to try to give you as many kind of ideas and examples to kind of go along with those things. So we're going to be talking about what a variable is. I know that sounds kind of, I don't know, it seems kind of bald and obvious, right? Like, what is a variable? Well, a variable is something that varies. But we'll talk about how that's used in psychological research. We're going to be talking about why measuring behavior can be so difficult. So what happens if the behavior that you're interested in can't be directly measured? So for example, I know a lot of people are interested in anxiety. Well, anxiety isn't directly measurable, right? Like, I can't go up to you with a ruler and measure how much anxiety you have. It's something that we really have to be careful about how we're measuring it, why we're measuring it, and the devices that we're using, whether it be self-report or physiological data. I don't know, it's a whole thing. We'll get into it. And then we'll talk about how we can be sure that our measurements are in fact measuring what we think they are measuring, which is going to bring us into a discussion of validity and reliability. Now, I feel like I always warn you at the beginning of these videos that not everybody finds this stuff fun or exciting. That's doubly true for validity and reliability. In the past, whenever I've taught this class, this actually seems to be one of the things that whenever it shows up on the exam, students are like, I don't remember any of this stuff. So I want to make sure that we kind of go through and give examples of those at the end there. I wanted to kind of start out by, by now at this point in the semester, we're reading articles together. So you should have already, read at least the first article that I assigned here. And one of the things that I think is really kind of exciting, and this is kind of a difference of generations here, because whenever I was a college student, I guess, Facebook was around. People were using Facebook. You had to have a .edu account to have a Facebook account because it was just for college students at the time. But we didn't really have like social media like we think about it today. And one of the great things about social media, there's a lot of things that I don't like about it. Obviously, I think everybody's kind of the same boat, right? Like, it's good and bad. One of the great things about it is that it has really changed the way that people interact with science. I guess that's kind of good and bad because we see a lot of people kind of twisting science and using it for misinformation and all this other stuff. But one of the really cool things that maybe you haven't thought about is that using social media, you can basically ask scientists questions. Go on Twitter and you can probably find a scientist, you can ask them a really interesting question that I wouldn't have been able to do whenever I was in your shoes. So this brings me to this tweet right here. Do you understand how cool it is that Twitter has given everyone who wants it direct access to a scientist? Like, no matter who you are, if you have a question about something, you can now literally just go to any scientist and ask them. How cool is that? Sorry for the kids. I gotta censor that right there. And then this guy comes up and he tweets Richard Dawkins, who is probably at least in the top 5, probably top 3 most influential living biologists or ecologists today. He asks him, is it true horses don't exist and every horse is just 2 people in a horse costume? And the lesson here is you have great power at your fingertips. So yes, you can ask scientists. Some of the authors of the papers we're going to read this semester, if you wanted to, you could tweet them, you could email them, you could say like, hey, I don't understand this part of your paper. And they'll probably tweet you back because scientists like talking about research and they like especially talking about their own research. Just don't abuse that power because you may get blocked like like in that case. All right, so let's start out by talking about operational definitions. Operational definitions is a very tricky subject because it sounds like definitions, like it sounds like what you would find in, Merriam-Webster or the Oxford English Dictionary or whatever. This isn't definitions like a bolded term definition like you'd find in your book where it defines what it is. An operational definition is a way of talking about defining something so that you can use it. So let me explain why this is so important in psychology. Psychology is a difficult science because what we are studying is not always easily measurable. It's often very abstract. I gave you the example of anxiety just earlier, but you can pretty much any kind of subject area in psychology that you're interested in. It's abstract. It's something that's hard to measure. Like if I'm talking about anxiety or depression, or if I'm talking about body image and self-esteem, those are things that are not easily measurable. Which means that if we're trying to think about this scientifically, we're trying to think about this systematically, we have to find ways to turn those ideas, anxiety, depression, body image, self-esteem, we have to be able to turn those things into measurable constructs and measurable variables. So if you were interested in aggression, let's say that you're interested in aggression and understanding aggression, how do you measure it? And this is, I wish that we were a little more interactive here instead of me just kind of yelling at my computer monitor while I have my webcam on. But I'm sure that you probably have some great ideas for how we might measure aggression, right? I would think, I'm going to measure aggression because I'm looking for whether or not somebody's mad. Okay, cool. How do we know if somebody's mad? Well, they're mad whenever they are angry or whenever they are feeling hot under the collar, so to speak, where they're steamed. Okay, those are still not things that I can always directly measure, right? So, because it varies from person to person, because it isn't something that we can't always see, we have to be very careful about how we're defining what aggression is. So operational definitions are going to help us take something like aggression, which we can have a lot of variability and a lot of difference in opinions about how we define aggression. Operational definitions are going to help us kind of solidify and measure what that is. So let me give you an example. And I'm going to, like I said, I'm going to give you a lot of examples in this class. Sorry, I forgot to start my stopwatch because I don't want this to go over an hour. So an example of an operational definition for aggression could be, how often does someone use curse words in their language whenever they're talking with you for the next 10 minutes? Okay, so the idea here, and this is a little bit tricky because I'm assuming that if somebody's angry or if they have more aggression, they're going to be using curse words more often, right? Now that's an assumption. We know that's not true for everybody, right? So yes, it does vary from person to person. But that is something that I can directly measure. I can count on my hands how many times somebody uses a cuss word in front of me. So that is the operational definition for aggression. Is it the best example is it the best operational definition for aggression? No. But it is one way that we can take something that is very amorphous and very abstract like aggression and turn it into something that we can systematically study. Because then, and this is one of the ways that it really helps me kind of think about what is a good operational definition, is ask yourself, what is the difference between somebody who is very aggressive and somebody who's not very aggressive? What things would I be looking for if somebody was very aggressive to distinguish them from somebody who is not very aggressive? We could use profanity and cuss words, right? But we know that's not a really good way of doing that. We could also look at blood pressure. We know that when our people are really aggressive, their blood pressure spikes, their breathing becomes heavier, their heart rate increases. But those aren't always the things, right? So we have to be careful about what operational definition we are selecting to define these behaviors, but also we have to be very careful to communicate that to whoever our reading audience is. So you're going to see this a lot in the articles that we talk about this semester, that people will talk about things like body esteem, and they'll be very careful to say, here's how we are measuring body esteem, so that way there's no kind of ambiguity about where that definition comes from or how it's being measured. So this is all just to set up what this chapter is all about. This chapter is all about how we decide what we are measuring. And when you put it like that, it sounds really exciting, right? So here's another example. Let's say we're interested in studying school achievement. So how well is somebody doing at school? And so you can imagine if I ask you, there are two people. I want you to tell me which of them is doing better in school. What things would you be looking for? What kind of data would you be looking for to determine which of those two students is doing better? Well, one way that we might do that is we might ask them straight up, what kind of grades do you get? What is your GPA, right? That is an example of a self-report, right, which we'll talk about in a second, where we're asking somebody, they're giving us a response, and that could be a measurement of school achievement. Now, already you're probably thinking like, wait a second, I don't always trust that. If I ask somebody what their GPA is, maybe they don't know, or maybe they're lying. Both are good points. I'm glad you made those points. But just keep in mind that when we talk about operational definitions, there's not always going to be one perfect answer. And I know this is a theme that I've been talking about this semester, that one of the reasons why I really love research methods is because it allows you the opportunity to be creative, and there's not always going to be one perfect solution for everything. And this is one of those examples that when we're talking about school achievement, we might go about asking people, what grades do you get? And that might tell us if somebody's a good student or a student who needs a little bit of help or needs some improvement. But there's a good chance that you can find a better measurement than that for your specific needs. So maybe, let's say that I am interested in studying students that are right there on the cusp, that are right there on the borderline. So I don't want to just ask what kind of grades do you get. Maybe I want to check their transcripts. And that is absolutely another way that we might do this, is I can go through and I can look at their transcripts and determine what their GPA is, and that can tell me about their school achievement. Or if I had even more time, what I might do is I might just go over to those instructors and say like, hey, how's this person doing in your class? That is probably going to be actually the most comprehensive way of understanding school achievement, because if I'm asking an instructor, they might be able to tell me, has this person been coming to class? What are their grades like in that class? Do they contribute to class? And things like that. Those, all that other stuff you can't really measure just by asking them what kind of grades do they get, or just looking at their transcript. So again, how we decide to measure school achievement really depends on what we're interested in and how much time and energy and resources we can invest in that specific study. Here's one more example. This video is less than a minute long. I highly encourage you to check it out. It's a little bit of an older video, but it's this guy who was in his Psych 101 class. They were covering the concept of dishabituation, and so he comes up with a really compelling example of dishabituation. So dishabituation, if you are studying behavior or applied behavior analysis, you're going to come up with dishabituation a lot, because it comes up a lot whenever people talk about like addiction, or when they talk about fear or trauma. Dishabituation is the reappearance or enhancement of a now weakened response due to the due to the presentation of a new stimulus. So you can imagine this being like, this is kind of a weird example, but for me, like with coffee, I drink coffee a lot, and so I have habituated to caffeine. I need more and more and more caffeine in order to kind of be stimulated by it. So if I go, let's say, a few months like that, and then somebody gives me like a Rockstar energy drink, and I don't really drink energy drinks, but I drink that energy drink and I have this all new boosted kind of stimulation from it, that would be an example of dishabituation, where that old kind of feeling has been rekindled by a new stimulus. So if you watch this video, you'll see an example of that. But, and I think it's maybe a more compelling example than what I just gave, how could you study that, right? How can you really study that in a systematic way? In this video, you might look at how much does somebody startle or jump in the presentation of a fearful stimulus, right? So you might measure, how far off the seat do they jump, or how long does it take them to return back to work. Both of those would be good operational definitions for dishabituation, but only really for this specific scenario. So again, operational definitions, you have to be very clear about what it is you're trying to measure, because the goal is that you want your reader or your audience to know exactly how you studied what you're studying. Or in our case this semester, we want to know exactly how these scientists and these clinicians and counselors, how exactly they studied what they studied. Okay, so just to talk a little bit more about operationalizing something. When we operationalize something, we're taking something that's abstract and we're turning it into something that is empirical and measurable. So we're turning something into something that we can count, something that we can directly measure, whether that be with our eyes or with a scale or with an MRI machine or with an EKG measuring heart rates. When we operationalize something, we're turning it into something empirical and observable. There are lots of reasons why we would do this, and I've talked about some of them. One of the things that I've kind of been emphasizing this semester is empiricism, and I didn't include that word on this slide. So let me write this out here. So empiricism, if you remember, is the ability to kind of measure and agree on something. So if I measure, how tall my iPhone, I almost said this is an iPhone, this is not an iPhone, how tall my phone is, you can measure my phone as well, and we can come to an agreement on it because that is empirical. And so operational definitions allow us to take behavior and to turn it into empirical data, to turn it into something that can be directly measured between me and you and everybody else you know. So it removes subjectivity and it removes bias. I can't, if I'm measuring this and I want it to be really tall, if I'm measuring it in inches, it doesn't matter how much I want it to be tall, it's going to be the same no matter what. And that's something that we really have to watch out for in psychological research, because a lot of times, as you'll see in a couple of other examples, if I want to if I have a suspicion about a hypothesis, like I think that small dogs bark more than big dogs, I might call something like a whine or a chirp a bark if I suspect that small dogs bark more often, because I have this bias going into it. So operationalizing something is going to help us remove that bias and that subjectivity that me, the observer, and the measurer are going to deal with. Now, normally you're going to need to come up with an operational definition for both your dependent variable and your independent variable. We haven't talked all that much about dependent variables and independent variables. We're going to talk much more about that in the next chapter when we talk about experimentation and experiments. But the dependent variable, that's what you are measuring, and the independent variable is like the groups that you're making or the conditions that you're making. And I guess maybe we have talked about that a little bit, but we'll go into more detail about that later. So let's look at a couple examples here. So this table I included in the lecture slides, you can kind of see here. So like, let's say that car ownership. Car ownership is kind of a weird variable to measure, right? How might you measure car ownership? Well, one way that I might do that is I might just straight up ask you on a questionnaire, do you own a car? Yes or no? And that is a way of measuring car ownership, because I'm taking something that's abstract and I'm turning it into something that you and I can measure. I can give you a questionnaire and you can respond to it. Here is another example. So expressing gratitude to a romantic partner. How might you operationally define that? That's really that's even more abstract, right? Expressing gratitude. And so here, if you ask somebody, I tell my partner often that she or he is the best, and we could rate on 7 levels from strongly disagree to strongly agree, which is called a Likert scale, which we'll talk more about later this semester. When we're going to have a chapter just about self-report data. But that is an example of taking something that's really complex and abstract, like gratitude, and turning it into something that we can directly measure, where we can measure it, where I can give you this scale, and you can respond on it, and then I can show it to everybody, and we can all agree what you what you selected here. My dog just opened the door and then he left, being bashful, I guess. He did that, what, in chapter 1? Maybe it was chapter 2? I don't know. Another example would be the type of story told about a scientist. This is kind of weird, right? But a type of story. So this would be like if, and this is an independent variable, where if I gave you one story about Einstein and then one story about Marie Curie, or if I gave you a story about a scientist that was positive and one that was negative. In that case, I'm taking something that is abstract, which is stories about scientists, and turning it into something that we can agree on and measure and quantify. This one's maybe a little bit easier. What time children eat for dinner? I can turn that into a self-report scale, right? I can turn that into, just tell me, what time it is. Or I can observe and clock that with a stopwatch. Or I can ask people to record this throughout the week using a food diary, and then they can use that to directly report their data. So I guess what I'm trying to say here is that no matter what behavior you're interested in studying, you can study it, but you have to be careful about the operational definition that you use, and that there's more than one possibility, that there are lots of different ways to do this. If we wanted to, for car ownership, I could categorize that as just, I'm going to go to people's houses and see how many cars they have in their garage. That is one way of doing that by direct observation, very different than self-report, but also an operational definition. Oh boy, so I gave a lot of examples here. I'm just going to burn through these really quickly for the sake of time. What would be a good operational definition for happiness? Happiness, I might say, how many times do you smile in 1 hour? That's an operational definition for happiness. For outgoingness, I might say, how many times do you go out at night during the week? Do you go out twice with friends during the week? Do you go out once with friends? Do you go out never with friends? That might be a measurement of outgoingness, because somebody who responds that they go out 7 times a week is going to be more outgoing than somebody who goes out no times a week. Tidiness, I might look at this as how many items of clothes do you have on your bedroom floor, where if you respond none, then that means you're very tidy. If you respond a lot, that means that you are not very tidy. What about a love for reading? I could say, I could ask you on a scale, or no, not even on a scale, I could just ask you, how many books did you read last year? That would be an example of a love for reading, where people who respond more books love reading more than people who respond fewer books. But even here, you can tell that there's some problems with that definition, because you can love reading, but maybe not read books, right? Maybe you read I was gonna say magazines, but I don't think people read magazines all that much. Maybe you read stuff online, right? Maybe you read Wikipedia articles, and you love doing that, right? That wouldn't be captured if I just asked, how many books did you read last year? Respect for authority, this would be, we could again ask this on a self-report scale, but we could also see, like, all right, I give you, a list of 10 things to do, and if you follow all of it, then maybe that shows that you respect authority. Or if you don't do very many of them, then maybe that means you don't respect authority. Creativity, this is another hard one, because I could say, how many works of art did you work on last year or last month? Okay, or I could say, how many electives have you taken so far? Both of those are kind of measures of creativity, but they kind of measure different sides of creativity. One is kind of doing things, and one is more kind of experiencing things. Anxiety, as we're going to see this semester, there's a lot of ways to measure anxiety. Most times it's done with self-report scales, but you could also look at things like heart rate, right? You could look at respiration rate. Those are also measures of anxiety. All right, so transitioning a little bit here, we can talk about scales of measurement now. So as we're talking about the variables that we're working with, we need to think about their scales, because ultimately the reason why we're operationally defining this stuff is because we want to be able to compare. We want to be able to compare people and say, all right, this person is more creative than this person over here, or this person is more anxious than this person over here, or this group is loves reading more than this group over here. Or maybe this is a more positive way of thinking about it, is before and after. Before, people didn't love reading, and then using this reading program, now kids love to read. Well, how do we measure that? That's the kind of the object of the next couple of slides here, where we talk about the scales of measurement. This is, by the way, absolutely going to show up in your PSYC 308 class, statistics for psychologists. Those of you that are psych majors that are going to continue on this sequence, stats is going to be the next part of this sequence, and you're going to be talking about scales of measurement in that class. So here is an example. We know that a 3.2 GPA is higher than a 2.2 GPA. Why? Well, because one value is higher than the other. But we also have a general idea about how much higher that is, right? Because you know that's basically a letter grade above. 3.2 is a letter grade above a 2.2. They are on the same scale. So why is that important? Because let's say that if I asked, you know, how are you doing in school? And you said, I have a 3.2 GPA. Okay, sounds like you're doing good. And then I ask somebody else, how are you doing in school? And they say, I'm doing great. Okay, cool, but what does that mean? Great and a 3.2 GPA are not on the same scale. They're not the same scale of measurement. So one of the things that we're going to be emphasizing is that whenever you're measuring this stuff, it should be on the same scale of measurement so that you can make these kind of direct comparisons here. Here's another example. So if I was interested in what the most liked NFL team is by state, and I asked that in Massachusetts, I might get 85 responses for the Atlanta Falcons and over 7,000 responses for the New England Patriots. In this case, this is a little bit trickier. How do we compare these? We're mostly just comparing in terms of favorability. But if I'm trying to compare Falcons to Patriots, that's a little bit different than comparing GPA to GPA, which brings us to these different scales of measurement. There are 4 different ones, and so for your quiz, I'm going to be asking you a couple of instances of what scale of measurement is this. So here we go. The first is called the nominal scale of measurement. The nominal scale of measurement is essentially where you're looking at things in terms of their categories. And this is kind of what we're talking about here, where we're talking about Falcons and Patriots. That those are teams, but they're words, they're categories to describe the type of fans that people are. They're Falcons fans or they're Patriots fans. They're kind of one of these groups. But you can't really say using this data that someone is more of a Falcons fan or someone is more of a Patriots fan, because there's no real scale here. There's no real measurement here. Instead, what we're talking about is categories. So we might say something like, what is your favorite species, where, you might say a platypus or a dog or a pig or whatever. And so we can't really compare dog and pig and bonobo, and monkey. We can't really compare them because they're different categories. It doesn't make sense to compare them. But that's one level of measurement that we're talking about here, where we have these categories, and these categories are kind of they're kind of measurements in and of themselves. They aren't really scales that you can compare across categories. All right, so that's the nominal scale. So one trick before I move into the next couple of slides is that this really helps me, is that the scale of measurements, you can break this off into the acronym NOIR, N-O-I-R. And that's going to be nominal, ordinal, interval, and ratio. And so that tells you what the 4 scales are, but it also tells you the order of complexity. That as we move further down, so each letter gets more and more complex. So the ratio scale is going to be the most complex scales compared to the nominal scales, which are the least complex scales. Because nominal scales are just categories. They're categories of responses. Let's take a look at the ordinal scale then. Oh, sorry. Here, if I want to talk about, actually, now that I think about it, we could talk about about nominal scales like being apples and oranges, right? The whole idea behind, you can't compare these things, or they're like apples and oranges, is because we say that, like, okay, apples are their own thing and oranges are their own thing, and we shouldn't really compare them, which, honestly, if I'm being a little bit personal here, I think you can absolutely compare them things, because oranges are better than apples, and you can fight me on that. Now, if you want to come at me and say, like, Granny Smith apples, the green apples, okay, I can compare those. Like, I think oranges and the green apples, those are good. Those are both good. The red apples, though, I don't know. They're not as good as oranges. So most of the data actually are not going to fall into this kind of nominal category. Most of it is going to be quantitative, which means that we can take these values and we can compare them. We can break them down into a number that we can compare. Remember that quantify means that you can turn it into a number, and so quantitative data means data you can turn into a number. So an example of this would be height and weight. Like, you can turn your height into a number, you can turn your weight into a number, you can turn your age into a number. Whereas something like gender is categorical, right? Where there are different categories of it, and that makes it a nominal scale of measurement. All right, so the first that we're going to talk about is the ordinal scale. The ordinal scale simply means that that we have these numbers, but that or we can assign numbers to these things, but that the rank matters. So it's not just completely arbitrary, it's not just categories where we can't compare them. We can compare them, but the rank matters. So, first place versus second place versus third place versus 10th place, we know the order of things there. We don't really know the difference between first place and second place. Like, for example, if we ran a race, I wouldn't know how much time elapsed between the first place and the second place, or the second place and third place. I don't know that time. Maybe there was a huge difference between first and second, and not very, maybe just a small difference between second and third place. But I don't know that if I'm just looking at first place, second place, third place. So placing, that is an example of an ordinal scale. Another example of this could be, let me think for a second to make sure that this, actually no. Another example would be like talking about working class, middle class, upper class. So working class, middle class, upper class, those are ways that we generally talk about social economic status in the United States. And we know that working class, that folks that are working class make less money annually than people who are middle class, and they together make less money annually compared to the upper class. That is an example of an ordinal scale. We know the rank, but we don't know exactly, like, for example, if I said that I was working class and that you were middle class, I don't know. I know that you make more money than me, but I don't know how much more. So that's ordinal scale. Interval scale. Interval scale, again, the rank matters, but now we have equal intervals. So, an example of that would be GPA. So with GPA, there's not really a true zero. I guess maybe if you, if you failed all of your classes, you might have a GPA of 0. Don't hold me on that. But most people consider GPA to be an interval scale because 0 because a 0 GPA is usually hypothetical. It's not an actual 0. So GPA, thinking about GPA, we know the difference between a 2.0 and a 3.0, and we know the difference between a 3.0 and a 4.0. In that case, the interval is the same, that both of those are a difference of a letter grade. So we know it has equal intervals. We also know that rank matters, that a 3.0 is higher than a 2.0 and a 4.0 is higher than both of those. Let me give you one more example. Another example of that might be temperature. So, and this will maybe explain a little bit about what I mean about true zero. Think about Fahrenheit. So, with Fahrenheit or with Celsius, actually, that we know the difference between 30 degrees and 40 degrees, and 40 degrees and 50 degrees. So we know that which of those is higher and lower. We know that those are equal intervals. We know exactly how many degrees they are separated by. And also, there's no true zero. That 0 degrees temperature, Fahrenheit or Celsius, does not mean there is no temperature. It does not mean that there is an absence of temperature. So it's a 0, but it's an arbitrary 0. It's kind of this is a hypothetical 0. If you wanted to be very technical and say, well, what about Kelvin, right? Temperature in Kelvin, the Kelvin scale, that is not an interval scale because it does have a true 0. 0 degrees Kelvin means that there's absolutely no temperature, and usually the only people who measure things in Kelvin are, like, I don't know, chemists and physicists and astronomers, because we don't really have to deal with that so much in the real world. Ratio scale, and this is the most advanced. Ratio scale is where the rank matters. We have equal intervals, and we have a true 0. So exam scores are an example of a ratio scale. If you make 100 and your friend makes a 90 and I make a 0, we know exactly how much better you did than your friend and how much better y'all did than I did. And if I got nothing right on that exam, I'm going to get a 0. That 0 is meaningful. It's a true 0. It means the absence of any correct answers. Exam scores can be ratio scale. But be careful, because things like the SAT, doesn't really have a true 0, right? If you do the SAT, you can't make a 0. Unless you don't put your name on it or whatever. But generally speaking, as long as you put your name on it, you get some points on there. So not every exam score is going to be a ratio scale. So be careful. Does your exam, can someone actually make a 0? If they can make a 0 by missing every question, then that is a ratio scale. Kelvin is a ratio scale. Fahrenheit and Celsius is an interval scale. So here are some other examples in this table. I included this on here for you. Like IQ, for example, is an interval scale. It's impossible for somebody to have a 0 IQ. It's impossible for somebody to have a 0 shoe size. So those are both interval scales. If you have a size 10 shoe and I have a size 6 shoe, we know exactly how much difference our shoe sizes are. So that makes it an interval scale. All right. So, moving into the different types of measures now. So, we've talked about operationalizing variables, and this would be a good time to, we're switching gears here. We've been going a little bit more than half an hour, so it's a good time to take a break here. All right. I'm not going to try to speed up. I'm not going to try to go through this too quickly, but I'm aware that we're at the halfway point, and I need to make up some ground here. So, there are 4 types of measurements that we're going to be looking at this semester. The book only really goes over 3 of them, but I want to give you 4 because some of you are going to be doing things like educational research, and that does come up, not talked about too much in the book. So, let's go over that. And for each of these, I'm going to be using caffeine at, caffeine consumption as our variable of interest here, because that's something that I research and something that I love to do, and something that probably most of you as students in college are very familiar with. So let's talk about self-report. So self-report, this would be like recording someone's answers that they give you either in an interview or in a questionnaire setting. So if I just asked somebody, how much caffeine have you had today? That is an example of a self-report question. But we can make it a little bit more fancy and a little bit more technical as well. I could say on a scale of 1 to 7, with 1 being not at all and 7 being very much, I want you to tell me how much do you like caffeine? Or I like having coffee in the morning. On a scale of 1 to 7, how much do you agree with that statement? The advantages of this is that it's very cheap and easy to do. The disadvantages of this is that people can lie. If I am very self-conscious about how much caffeine I consume, then I might kind of fudge the numbers here a little bit, and maybe I tell you that it's less than it actually is. So self-report is good, but you have to be very careful because sometimes people can lie. The book at the very, very end of this chapter talks about social desirability, and that's absolutely something you would want to worry about. Because, for example, if you're talking about things like criminal behavior or sexual behavior, things that people can be a little bit self-conscious of, or drug use, then people might not report. They might not be totally honest because they're worried about being judged. Testing is another measurement style that we have, and this is the one that the book doesn't talk about. But testing, this would be like if you are giving a standardized test. And this standardized test is to help identify individual differences in behavior. So this doesn't come up all that much, but I wanted to put it out there because some of you will be working in these realms. But if you were giving somebody like like the MMPI or the standardized IQ exam, that these are often looked at as testing measures. I think the book kind of combines testing and self-report together, so just be a little bit careful there. But if I wanted to look at how, using caffeine consumption and measuring that with testing measures, then I might look at the differences between people before and after they have coffee, where maybe I have people who are in a coffee drinking group and then a water drinking group, and then I look at how well they did on an SAT or something like that. That would be an example of testing, because I am looking at these differences, these group differences. Or I could even look at before and after, where I'm looking at before someone has caffeine and then after someone has caffeine. Weird. It's very late at night, and I just got an alarm on my phone that somebody's at my front door. Probably fine, right? Probably. Actually, I'm going to go check on that. Give me 1 second. Alright, sorry about that. Turns out it was just the Amazon delivery person, which is, they came, not to tell you too much about when I'm recording, but it's quite late at night and it's Sunday, so they are working super hard. Alright, and I feel really guilty about placing an order if somebody is going to be having to work this late on a Sunday, which I guess I'm working this late on a Sunday, so I don't know. So the third type of behavioral measure is the third type of psychological measurement is the behavioral measure, and this is really kind of, I hesitate to phrase it this strongly, but this is kind of the gold standard, I think, of measurement, because a behavioral measure is where you are looking at somebody do something, and that's what you're counting, that's what you're observing, that's what you're measuring. So it's an outward explicit response. So for example, if I'm observing how many sodas or how many cups of coffee someone has each morning, that would be an example of a behavioral measure, where I'm seeing exactly how many they do. I'm not relying on self-report. I'm able to see it for myself, and I can record it, and then other people can verify that. Or if I give some people an option, where they can choose between caffeinated or decaffeinated coffee, that would be an example of measuring caffeine consumption using behavioral measures. Because if someone chooses caffeine, then that means they have higher caffeine consumption. The advantages of this is that it's a really great, easy way to record behavior. You can be sure that you're measuring what you think that you're measuring, and we're going to call that validity, which is something that we're going to be talking about a little bit later. And the disadvantages of this, though, the reason why is not always used, and in fact, a lot of the articles that we're going to be reading this semester, we're going to see that this doesn't get used all that much, is because it's very time intensive and very cost intensive. It takes a lot of time and a lot of energy. Imagine if you're observing somebody how many sodas they have each morning, or cups of coffee. You have to follow them around. You have to pay somebody to do that. They have to, and that's really intrusive. And also, if people are being observed like this, sometimes that might change the way they respond in that scenario, which is something that we'll talk about later this semester. It's called reactivity, sometimes called the Hawthorne effect. And then finally, we have physiological research and physiological measures, and this is measuring bodily activity a brain scan could be this. Measuring heart rate or respiration could be this. Measuring blood pressure could be this. Measuring galvanic skin response could be this. So if I were to look at how much does drinking a cup of coffee change my heart rate, that would be an example of a physiological measure. If I was looking at the brain activation of people before and after they drink coffee, that would be an example of a physiological measure. The advantages of this is that a lot of times the things that we are in, the whole premise of this chapter is that behaviors are hard to measure and that they're not always directly observable, that sometimes they're not outwardly observable. So sometimes it can be really helpful for us to measure things internally like this, and that can sometimes be more objective than other measures because you're actually reading it out on a machine, where you put on that blood pressure cuff and it tells you exactly what your blood pressure is. There's no debate about it. That's just what the machine has measured. So that's one of the advantages of it. The disadvantages of it is that it's not always the case that a behavior has a physiological difference to be measured. So for example, if I'm talking about being a Patriots fan or a Falcons fan, I can't really put somebody in a MRI machine and scan their brain and determine what kind of fan they are. I can't hook them up to electrodes to discern that. At least I don't think you can. Maybe you can, but but I don't think you can. So just to quickly review these four different styles, or these four different measurement types. Let me pick a research area real quick. Let's say that I want to measure something that is not super serious. I could talk about happiness, but I feel like I've used happiness already. Let's say attention to detail. Okay, I'm thinking of this on the fly. So if I want to measure someone's attention to detail, I can ask them straight up, how good are you at paying attention? How easily are you distracted? Things like that. And I can measure that with self-report. I can use using testing measures, so I can give somebody a really long standardized test and just see how thoroughly they complete it. Do they answer every single question? Do they read every single question? That would be an example of a testing measure. Behavioral measure, this would be like if I give somebody a simple or a time-consuming task, like turn 90 valves quarter clockwise, and then see, do they actually do that, and how completely do they do it? How consistently do they do that? That would be a measurement of attention to detail. A behavioral measure where we can outwardly view it and where we can see people do it. Or if we're talking about physiological measures, that one's kind of harder, but it might be something where I'm just looking at people who self-identify as being very attentive, and I measure their brains versus people who say they're not very attentive in a brain scan to look at those differences, or measure their heart rates, or even measure how long they sleep, or their quality of sleep. That would be an example of a physiological measure. All right, and this brings us into the final stretch. Thank you so much for hanging in with me. If you need to take another quick coffee break, because I've talked so much about coffee, then this next piece, I'm going to try to get us out of here in 15 minutes. I'm so sorry if this takes longer than an hour like I promised that it would. So, reliability. Let's start with reliability. We're going to be talking about reliability and validity. Reliability, if you remember in the first chapter, I talked about how behavior is probabilistic. In other words, we don't always behave the exact same way every single time, that we behave differently in a variety of different contexts, and so our behavior is probabilistic. Am I a morning person? Most times. Not all the times, but most times. So, if I want to measure reliability, if I want to measure how consistent something is, I'm going to be looking at its reliability. Now, depending on your professor, some professors are not super happy with just thinking about reliability as equal to consistency, but that is a nice shorthand way of thinking about it. That reliability and consistency are very, very similar. That if something happens over and over and over again, the same way each time, it's reliable. So, are you a happy person? On a scale of 1 to 7, are you a happy person? Think about that number. If I were to ask you that, let's say at 7 a.m. tomorrow, would you have the same number? If I asked you at the end of the semester, right before you take the final, would you have the same number then? Maybe not. So reliability is a way of measuring the consistency of our measurement. So the consistency or inconsistency of that measurement to produce the same result. So the higher the reliability, the more consistent that measurement is. And what we want to strive for in our research is to have a measurement that is reliable, that produces the same result each time. Which is why a question like, are you a happy person, is not a super reliable question, because there's so many things that could change the way that you respond to that question. So you want to come up with a more savvy question, maybe a more, have some finesse here, where you could say, like, on any given day, do you find yourself more in a positive mood or a negative mood? That question is more steady. It's going to be more reliable. It's going to produce the same outcome, probably, compared to this other question. So another way to think about this is, if we reran this experiment again, would we get the same results with these participants? So there are a few different kinds of reliability that we're going to talk about. You can find these in your book as well. Test-retest reliability, this is very easy. If we want to make sure that our measurements are reliable, we can just do the same thing again. If we do the same thing and we get different results, that's a warning. That's a bad sign. So if you took a calculus exam and you made 100, and then you took it immediately again, without studying, without that much time away, and then you made a 50, there's something wrong with that exam, right? There's something wrong with that exam that should be checked out. It could be something with the grader, it could be something with the machine, who knows? But that's a cause for alarm. We would say that test has low reliability. If I made a memory test and someone scored on it really low, and they took it again, and then took it again, and it said they had a really high score, again, that's worrisome. That means we have low reliability, specifically low test-retest reliability. Another example is, and sorry, this GIF will make sense in a minute. Inter-rater reliability is, sorry, I can't look at that GIF because the scene that it comes from makes me laugh too much, so I can't look at it. Inter-rater reliability would be like, if you are measuring something, you're observing something, and you want to make sure that there's no subjectivity in it, then it can be helpful to have multiple people grade or measure that same thing too. And if those people, those judges, those raters, come to an agreement, that's good. That means that your test is reliable. If you find that you have different results, then that's an issue. So an example here would be like, is your professor an effective instructor? So if someone comes in and they try to do this, or actually, hold on. If your professor is an effective instructor, let's say that one person from the department comes in and they observe me teach, and they conclude that I'm an okay professor and I'm an okay instructor. Is that a reliable measure? I don't know. We would need to maybe bring in another person to come in, witness the same lecture or the same class, and have an independent report, and then we can compare those reports. If those reports agree with each other, great. It means that the two of you are reliable. If those two reports don't agree, then that means that the two of you are maybe not responding to the same behaviors. Maybe it means that your measurements are not exactly the same. So this is where the subjectivity of the observer can sometimes change the measurement. And that's something that we should be worried about, which is why a lot of times in articles you'll see when we're talking about observation, where you'll see people say, we had 4 people observe these and we have an inter-rater reliability of 95% or something like that, which is good. So an example would be like, if I wanted to know if this clip is, this clip of the show I Think You Should Leave on Netflix is funny, then I might show this clip compared to another clip, and then I listen for how many times I hear people laugh. Well, what counts as a laugh, right? Like a belly laugh, or what if somebody just smiles and breathes out really hard? That like that. Is that a laugh? I don't know. But you, me, other judges can look at that evidence. If we record it or whatever, we could look at those laughs, those guffaws, those smiles, and we can try to judge what is a laugh. We'll probably need to come up with a rubric for, okay, a laugh means that there's an audible ha, and that it lasts for more than a fourth of a second. That we come up with these criteria that we all agree on, so that whenever we then watch it, then we can come to a conclusion of there were exactly 5 laughs for this video. That would make it, that would be using inter-rater reliability. So an example that I have here, which I'm going to show you on the next slide, which I hinted at earlier today, was if I have a hypothesis, if a dog is small, then it will bark more than a larger dog. And I'm looking through these clips of dogs, and I'm going to count how many times each of them bark. And then afterwards, I'm going to give that video to somebody else, and they're going to do the same thing. If we come to the same agreement of how many barks we counted, that's great. If we don't, that means we have bad reliability, and probably what we should do is we should come up with a rubric to then say, here's what a bark is. It is something where you can see the dog's mouth open and close, and it's not a whine, and it's not a cry, and it has to be over 20 decibels, things like that. Then you do it again with that criteria, and you should get better inter-rater reliability. But that is what that is. If you want to see the example that I'm talking about here, there's this video of this cute little dog who looks about as big as a hamster, and it's kind of barking, and I like to show it in class and have everybody count how many times they think they hear a bark, and then kind of talk about why some of us have 11, some of us have 30. Why is that? It's because we have bad inter-rater reliability, and the solution to that would just be have a clear set of guidelines of what we are measuring when we say what a bark is. Here's how that's measured. You don't really need to know that for this class, but if you're interested, this is where this is computed, because you'll sometimes see this in some of the articles that we read this semester. Internal reliability, sometimes it's called internal consistency. The book calls it internal consistency. This is how some tests and questionnaires will have questions that essentially ask the same thing, where they will say something like, let's go with question 1 and 3 here. If I have this scale, how alone do you feel on a scale of 1 to 7? How much do you enjoy cooking on a scale of 1 to 7? And how supported by friends do you feel on a scale of 1 to 7? Questions 1 and 3 are kind of asking the same thing, or they're at least kind of trying to measure the same thing, which is how alone someone perceives himself to be. If someone here responds with a 7 and they respond here with a 2, that might be cause for concern that our measurement is not very reliable. Maybe it lacks internal consistency, because people are responding differently when they should be responding the same. And that means that we have a problem with the reliability of this scale. The way that we would want to try to fix this then, sorry, my bad. Hopefully you were reading this and you were, a warning sign came up, because you were like, wait a second, I'm not sure that makes sense. Because these two things would potentially be opposites, right? Where if somebody scores really low on this, that means that they feel alone. And so if somebody scored a 7 on this and a 2 on this, that's actually a good thing. That actually shows that there's probably good internal reliability here, because people are responding to these same kind of items in the same way. If somebody is being, a smart ass and they just put A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D on every single item, that person is going to give you bad internal reliability. They're not responding consistently for the same types of questions. But this is the reason why in lots of surveys, you're going to see a lot of redundant questions. And the reason why is because those researchers are making sure that their participants are paying attention, and they're actually doing it, like they're actually reading it and responding thoughtfully. One way to measure reliability can be using these kinds of scatter plots. These scatter plots, and I'm sorry that we're going longer than an hour. I actually really embarrassed because I thought we'd be able to get through this faster than that, and I don't want to rush, so I apologize if you hate me because I told you we'd get out of here earlier than this. But feel free to take a quick break. We're in the final stretch. It's just a longer stretch than I thought it was going to be. So feel free to grab a cup of coffee or a beer or something like that. Or a beer if you're over 21. Don't do that if you're younger than 21. One way that we can assess reliability is using scatter plots, and you probably have seen scatter plots before. They're a measurement of correlation where you have like two variables, one on the x-axis, one on the y-axis, and you kind of plot them out. So for example, if I'm measuring head circumference, and I'm going to measure that twice, maybe like once at the beginning of the year and then once at the end of the year. So Taylor's head is 50 centimeters circumference and 52 centimeters circumference. That would be an example of retest reliability, I know, but we could plot that here where, all right, Taylor scored on her first measurement right here and the second measurement right here, so Taylor's point is right here. That's the scatter plot. Good chance you had to graph lots of these in high school at least, or in any kind of math class you've been in. So so with that in mind, we're going to be using scatter plots to look at reliability of our measurements. So for an inter-rater reliability scatter plot, we might find something like this, where I have Mark's ratings and then Matt's ratings. And if I find that they are all over the place, there's not really a consistent trend here, that's worrisome, because it would look a little bit like this. That for Mark scored Jackie at a 2, Matt scored Jackie at a 3. Those are pretty close. Mark scored Jay at an 8, and Matt scored Jay at a 9. Pretty close. But if we look over here, where Peter, I don't know what Peter's doing. We take those same people that Mark observed Jackie at a 2, Peter scored her at a 7, and Jay, Mark had at a 9, and Peter had at a 6. Those are very inconsistent, right? Those are not very reliable. We would say that this is bad reliability. There's not a strong trend here. You either want a trend, pretty much for inter-rater reliabilities, you only want positive correlations that look like a linear trend like this. If you have it flat, that's worrisome. Anytime it's either straight up and down or flat when you're looking at inter-rater reliability, that is a problem. Correlation, other kinds of correlations, I don't want to spend too much time here because good chance you've talked about correlations a lot already in other classes, but people will quantify this and call it Pearson's R coefficient, and so the R coefficient is a way of telling you how strong a correlation is, and so an R of 0.5, for example, 0.56 means that there's a pretty moderately positive correlation here. And so that R is going to be able to tell us about the direction of that particular slope. So if it is positive and if it is strong. So 0.56, that is going to be a positive correlation, and it's going to be a mostly pretty strong correlation because correlations can vary between -1 and +1. The closer they are to +1 or -1, the stronger they are. The closer they are to 0, the weaker they are. And so that can tell us about the reliability if we know about the correlation of these variables that we're measuring. So for example, if we go back to this, right? So over here, we have, for these individuals, this is a very strong positive correlation because it's very close to a +1. That the R is going to be equal to +1. Over here, this is going to be closer to R is going to be equal to, I don't know, like 0.2 or something like that. Not super strong at all. Here, what we can see is this is a really strong correlation because it's, that trend is so close like that. Here, this is a pretty decent correlation, but it's negative. As you can see here, it's just moving with a negative slope. But it's not a super strong trend. Here, this is bad news because it doesn't look like a trend really at all. You can kind of blur your eyes, and maybe if you blur your eyes, it kind of looks like that, but not really. The data are all over the place. We would say that there's, not really any correspondence or any kind of correlation between X and Y here, there's probably bad reliability in that case. Which brings us to validity. So reliability is all about consistency. Validity is really kind of about accuracy. So some tests can be reliable, but they can not be valid. What does that mean? Just because something is consistent doesn't mean it's a good measurement, right? So let's say if I was measuring head circumference, and I were to say that that was a measurement of intelligence. That's bad, right? That would be a reliable measure, but not a valid measure. It's not an accurate measure of intelligence. It's reliable because it doesn't matter how many times I measure the circumference of your head, I'm going to get pretty much the same measurement each time, but it has no bearing on how intelligent you are. So some tests can be reliable, but they may not always measure what they think they're measuring. You're going to see this a lot when we talk about intelligence testing. Intelligence testing is notoriously like this, where just because it's consistent doesn't actually mean that it's measuring intelligence like it purports to actually measure. So you can think of one, and again, this is kind of a shorthand way of thinking about it. Reliability is consistency in your measurements. Validity is accuracy in your measurements. But really, validity, and again, that's the shortcut way of thinking about it. Validity is the degree to which the things that you are measuring actually are what you are measuring. And there are three main types that we're going to talk about here. The first is face validity, or face and content validity. Sorry, I shouldn't have put the dash here, or what is it called? The backslash. So content validity is, to what degree does your measurement actually measure all the facets of the behavior you think that it's measuring? So if I use, let's say, if I'm trying to measure attention and I'm measuring where someone's eyes are using an eye tracking machine, that's cool, but there's more to attention than just eyes, right? And you know this because there are times where people make eye contact with you, but they're not actually paying attention to you. So eye contact could be a measurement of attention, but it's not the only measurement of attention. There are other parts of attention that are happening that may not be measured. So we would say that that measuring someone's eyes are maybe a good measurement, but maybe not super valid. That it can be reliable, but not super valid. Another example, and here I like to pick on intelligence testing because I don't really like intelligence testing. But if an intelligence scale asks only trivia questions about history, we could say that that's not a very valid measurement of intelligence, right? Because it's not measuring math or reading comprehension or logic or reasoning or visual discriminations or semantic reasoning, or analogies. There's so many different other ways to measure intelligence than what I just mentioned, but much more than just asking questions about history. Here, we would say that this might be a reliable measurement because people who are really good at history trivia are going to keep scoring the same consistent high scores, but it's not a very valid measurement of history. Face validity, on the other hand, is, does the measurement actually look like what we think it's measuring? Which sounds very similar, but face validity is kind of like saying, does the measurement look like it's measuring what we think it's measuring? And that is subtly different than content validity, where content validity is saying, is it assessing all the aspects of that behavior? This face validity is saying, is it measuring what we think it's measuring? And then finally, criterion validity is the degree to which the measurement that we have is predictive of a behavior. My favorite go-to example of this is SAT. Ooh, my southern accent came out for just a moment there. Is SAT scores. SAT scores are used a lot throughout the country, and really they only measure one thing, or I should say they only predict one thing, and the only thing they predict is how well someone does their freshman year at college. That's all it measures, or that's all that it predicts. It doesn't predict how well somebody's going to do their final year of college. It doesn't measure how well they'll do their second year of college. It only predicts how well they'll, and it does a pretty good job of that. People who score lower SAT scores generally have lower first-year GPAs than people who scored higher on SAT scores. But the interesting thing is, if you look at seniors and you look at people who had low SATs and high SATs, there's no real difference between the GPAs they have. So if you're like me, I did not have a very high SAT score. I'm not ashamed, I'm not embarrassed to say that if you have a low SAT score, doesn't really have any impact on your overall GPA or even your sophomore GPA. It's kind of interesting. And so here you can kind of see, you know, like so criterion validity is kind of like how predictable is your measurement. Where I could look at this and I could say, like, if somebody scored low on the SAT, that means that they're probably going to have a low freshman GPA, which means that SAT has good criterion validity. Another example here, which, I'll give you one, and it may show up on a quiz, depending on which version of the quiz you get. But height and weight, for example, are valid measures, or I should say that height is a valid measure of weight. Where if someone is taller, they tend to weigh more. There's just more body of them available. There's more bones, more epidermis. If I know that somebody's really tall, I can probably get the taller than average. Then I can probably assume that they're going to weigh more than average as well, and that would be an example of criterion validity. All right. So here is another example where correlations can help us. With correlations, if something follows a strong correlation trend like this, if these two values, these two measurements, the test that you give, the measurement you have, and then the outcome variable that you're measuring, if they seem to be on a scale like this that is positively correlated or even negatively correlated, that's good. That means you have good criterion validity. If they seem to not be super correlated, that can be okay too. It just means that there's weak criterion validity here. And then finally, we have construct validity, which, this one is kind of what the book refers to this also as discriminant validity, which is to the extent to which your measurement actually reflects the theoretic construct that you think that it's measuring. So this would be like if I am measuring depression and anxiety are really good examples, because as you know, depression and anxiety can occur together even though they are separate. They seem to be related even though they are separate. So it's really important for us when we're coming up with measurements to measure depression that we're not also measuring anxiety. So if I'm asking a question like, how worried are you right now? That is a question that can measure both depression and anxiety. So we would say that it has bad discriminant validity. We don't know, is it really tapping mostly into this participant's depression or this participant's anxiety? That's tough. Something that has good construct or good discriminant validity would be just looking at, if I'm thinking about depression again, I gotta be careful here. Do you find in recent weeks that your physical activity level is lower than it normally is? That is a question that is specifically targeting depression and less targeting anxiety compared to the other one that I just mentioned about being worried. So that question has higher discriminant validity than the others. This is really, really important, but honestly is something that you're going to be dealing with more kind of like at a higher level in your psychological studies. So like when you're in research methods 2, this might come up, and if you're developing a questionnaire, this might come up. But this really, this is hard stuff because it requires you to be thinking about the theoretical construct and those variables that you're aiming to study. So the way that we're able to test that is to look at other previous tests, look at whether or not those tests have overlap with these different constructs, like depression or anxiety, or if you want a different example. Another example we talked about at the beginning of the chapter was body image and self-esteem. Those two things, they can go hand in hand, but they are separate. You can have somebody who has really bad body image issues, but has really great self-esteem. Or the opposite, where somebody has really bad or really great body image, but really low self-esteem. So you want to make sure that your questions are differentiating those two, so that way they have good discriminant validity. Here is a great flow chart that hopefully will help you if you are looking at this stuff, taking the quiz or whatever. External validity, we'll talk later in the semester, but it's something I love talking about. But that is pretty much all that we have time for, and we're pretty much done with everything. Thank you so much for hanging in there. Give me one quick second. I'm going to pull up a quick surprise for you for hanging in there at the very end. All right, so here you go. Here is your prize. This is a picture of me whenever I was like 3, so this would have been like 1991 or something like that. One of the earliest pictures I have, I think, of me riding a horse. Why am I screaming at the photographer? I don't know. There's so many questions about this thing that I don't have that same outfit, unfortunately. But now that I'm thinking about this, I should, I don't know, go to Goodwill or whatever and see if I can find some red overalls and a striped shirt like that. I would love to show up to my parents' house one day dressed like that again. Oh man, you can even see I have a bad hairline even back then. My hair is already receding at that early age. So I'm sorry I didn't have a dog to show you at the end here, and I'm sorry that it took way longer than an hour, but hopefully this was a little treat for you at the end of the video. Thank you so much for tuning in. If you have any questions, just let me know. Otherwise, see you later online. Bye-bye.